one of the other big questions is what happens when this park loses its glaciers? What will it be called? Once Glacier National Park or Glaciated National Park. So when we call Glacier National Park, it got its name not from the glaciers that we have here today. It actually got its name from the giant ice titans of the Pleistocene that I was talking to you guys about at the stop before lunch, that carved and shaped this area and landscape. But the glaciers that we see today actually formed during a brief cooling period, like a mini ice age, that happened between 5,000 and 7,000 years ago. And so these are basically small alpine glaciers, much, much smaller versions of what was going on during the time of the Pleistocene. Now, this park was established in 1910, but people have been coming back here and visiting the area as far back as 1850. Does anybody know how many glaciers we had at the time the park was established in 1910? 105 years ago. Any idea?
150?
Yeah, 150, exactly. We had 150 glaciers here in Glacier National Park. 105 years later, which is not too long if you think about geologic time. Do you know how many we have now?
20.
25.
25.
So between 1850 and the present day, we've seen a 90% decrease in our glaciers and ice here in Glacier National Park. Now, how do you know if what you're looking at is a glacier? So we go by U.S. Geological Survey standards. So we say that it has to cover a minimum of 25 acres. It has to be at least 100 feet thick. And more importantly, what distinguishes glacial ice from just regular ice and snowfields is that it has to be moving. Glaciers are always moving. Now, the molecular structure of glacial ice is different from that of regular ice. Now, a lot of people make the mistake in thinking that glacial ice is much more dense than regular ice. That is not true. The density is about the same. What is different is the amount of air that you see in the ice. So if you're looking at an ice cube and a piece of glacial ice, they are the same density. Now, an ice cube, you can see through it, right? Because it has a lot of air in it, a lot of air pockets. Now, glacial ice does not have as much air. It only has about 20% of air in it at most. And so basically, what you're looking at is a lot of the light refracting off. So glaciers have that bluish hue because there's not a lot of air bubbles so that you can see through it. So basically, the longer wavelengths, which is the blue light, is what you're seeing basically reflecting off of that ice, just because there's not as much air pockets inside of it. So it's still the same density as regular ice. There's not as much air. Now, the fact that it has to be moving, when I talk about the molecular structure of ice, basically the bottom layer gets this kind of plastic-like ability where it slides obviously in the direction of gravity. Now, the top layer of ice cannot keep up with the bottom layer. So basically what it does, it's like almost like sliding a deck of cards. When you take a stack of cards and you just kind of slowly slide them, you see how it kind of just creates those, how the cards kind of slide out and create like little mini steps or ripples. And that's what you're seeing in the ice here, in that glacial ice, is the top layer can't really keep up with the bottom layer, so it folds and cracks on itself. And that's how you get a lot of those crevasses and such, which is a really telltale feature of moving ice. So you're looking at 3 glaciers here. This one right up here is called Salamander Glacier. It looks smaller than when we were hiking farther in because this ridge right here kind of blends in really well and it's hiding part of the tail end of that glacier. Now up here, this glacier will probably be declassified sometime soon. That's Gem Glacier. If you are at Logan Pass on a clear day, sometimes you can see just the hint of it from the visitor center, which is pretty cool. And this is Grinnell Glacier, or what's left of it. It used to come out all the way out here. So you see this weird rock surface feature, how it kind of looks like it was sliced and cut. That glacier extended all the way out here at one time, so that's where the end moraine was, and it's basically been moving back and receding over time.
What about
Now,
that one up there?
that is not a glacier, that's just an ice field or snow field. Where it's nestled in that nice little area, it just takes a long time, it doesn't get a lot of sunlight, so it just takes a long time to melt. But it's not a glacier. Now, at one time, it's kind of hard to imagine now, Salamander and Grinnell were all one glacier. And in about 1926, 1927, the two split. Got hot, obviously, with climate change over time, and it actually formed into two glaciers. So I like to do like silly glacier trivia sometimes, and I ask people, in recent times, have we gotten more glaciers or less? And the answer is we've gotten more, but ultimately it's because of melting. Another big glacier that did that was Jackson and Blackfoot at one time were one glacier and then split into two over time with the melting. So here is an interesting photo. Obviously it's hard to see from far away, and I'll keep it up and let you guys pass it around. But this was Grinnell Glacier in 1910. They took this photo in 2012, same time of year, same place, and you can see how much it has shrunk just in that amount of time. And if you look at the photo in 2012 and you look at it here 3 years later, you'll see that it's even smaller and there's more of a lake. So we are kind of the poster child for climate change here in Glacier National Park. Now, why are glaciers significant? What do they mean to me? I used to think that when I lived in South Florida. Shame on me, I was a Floridian once and kind of had that mindset. So basically, glaciers everywhere account for about 60 to 80% of our fresh water that we use for drinking, for our crops. Not just in Montana, we're talking about worldwide.
What is this creature?
That is a hoary marmot. Get out of here, marmot. Mammals always get in the way of my glacial talk. Taking my thunder. Go, get out of here. Okay. So basically, bottom line, our glaciers are melting, and what's going to happen is, the scariest thing about it is we don't really know. There's so many unknown variables. We've never really seen changes like this in our lifetime, before. So obviously, it's a lot of unknowns, and we're going to see a lot of changes and a lot of cascading things going on as a result of these glaciers melting. But one thing will always be certain is that this place is absolutely amazing. Grinnell Glacier, Glacier National Park, this will always be a place to come to get away from the craziness and hustle and bustle of everyday lives. This will always be a place for us to escape to and come to year after year, just to get away from everything and kind of lose ourselves in this beauty. And this place will always be beautiful. And whether you come here next year or years from now, or your family comes here when they're older, look for some of these changes. Obviously there'll be some benefits and there'll be some losses. But like I said in the beginning, this is an ever-changing landscape, and it will continue to do so. Thank you very much, guys, for coming on this hike with me. Yeah, if you guys want to check out some of these pictures, in a little bit I'm going to head down kind of closer to the water and head out that way. I'm not going to walk on the glacier because it's really dangerous to do right now, I've been told. But I kind of want to get a little closer. You guys are welcome to come with me. I really want to check out the stromatolites down there that I was talking about. I'm so